Thank you, and it's a delight to be back. So first of all, I have to introduce myself as a naive idealist and someone who believes that you can really make great things happen despite things that you may believe are against you or are impossible. So as I make my way through this presentation, you could claim that I'm a naive idealist, but the buildings that I'm going to be referencing either in part or entirely achieve these ideals. So you've got to believe, and let's talk about that. But in 10 years with the Design Review Panel, reviewing mostly condos, there's a big shift happening to more and more rentals. Condos are valuable additions to the city and are short-term investment vehicles. Rentals are long-term. And the aesthetics, the design assumptions, the materials, the preoccupations have been so dominated by one sensibility, we may have forgotten that it doesn't have to only be that way. So I hope you can share with me in a reminder, perhaps, of the way that the next round of development in the city can be. So believing. These projects are going to be referenced sometimes directly, sometimes indirectly in the presentation. And in this project, I had to believe that we could design an acre green roof, a LEED Platinum building, and have it designed and constructed in 24 months. I had to believe that. And in order to do that, it was built like a factory. Those are insulated metal sandwich panels on the exterior. On the interior, it's a dramatic student environment with about 10% of the total area, so 20,000 square feet of space made explicitly for shared learning. There are the sandwich panels and there are the solar shades, so 24 months from start to finish. In this project, I had to believe that we could have constructed 40,000 square feet on top of an existing building, and I'll show you a little bit more about this one in a few minutes, on top of an existing building in 4 months, and innovate with a timber construction in order to do so, and get these kinds of spaces on the interior when it was all done. We'd never done a net zero building before. And in this building, we had to believe that working with a construction manager and a very, very strong-minded client, that we could achieve net zero on a what should I say, a very meager budget, and celebrate timber and student life and places of repose for social learning in the building. And go through the iterations that it takes to get to a net zero building, and I'm definitely going to talk about that. And in this building, we had to believe that we could insulate every other piece of it, this is McCall Street in downtown Toronto, every other piece of it so well that we could provide a great display for student life inside OCAD University and still be a net zero building. Okay, So colleges and universities are constantly under pressure to innovate. As you know, the demographics across Canada and colleges and universities changing rapidly. The enrollments are changing rapidly. The needs of students are evolving. And what I've discovered, having worked both in the commercial and the institutional sector, is that they're committed to meaningful innovation. They believe in design, and when a building's designed well, they know, they can see it because they get more applications, they have longer retention of their staff and students. They believe in design. It's quite remarkable. And they also know that when student life is better, student outcomes are better. Very interesting that they actually fully believe that. And having worked in many colleges across Canada, I can tell you unconditionally that that's the case. So I want you to park that introduction for a second And this is where my naive idealism comes in. I'm hoping that by the end of this you'll have memorized these 6 numbers and 1 letter, because I think this is going to be the shortest form of zoning bylaw for mid-rise that you will ever see. These are the 6 numbers, that's it. We're going to dispose of all the other paper that you could possibly need, and this is it. So we're going to save many trees. 0, that's an easy number. Imagine, if you will, actually going to go back a step and just say that. Imagine if there were some assumptions that were so self-evident that they never need to be discussed. They are the silent underpinnings of everything that we do. We have many of them, all of us, in every culture, in every profession we do. But imagine if I could ask you to replace or add these to your silent underpinnings of everything that you do. And it's going to be these 6 numbers. Now, they represent a lot of other issues, but it's just 6 more, not that many more. I can tell you that in my 10 years with the Design Review Panel, there are no projects that I know of that use these 6 numbers as self-evident criteria. They maybe used some of them, but they didn't use them as the starting point or irrefutable reference points. They may have been there, but the pressure of development caused them to be eroded. So I'd like you to have them and be thinking about them when you're finishing your projects. I've seen about 400 projects at the Design Review Panel by respectable architects, 2 of them in the room here now, and many others. And so I just thought, after having seen these 400 projects, I thought, well, what would be a great set of references for the mid-rise projects that you're undertaking? So self-evident assumption number 1, we know the province is headed this way. We know the city is headed this way with the Toronto Green Standard. We know that the federal government's headed this way. Why don't we just say 0 net energy? It's got to be there. The next one is part of the mid-rise and avenues guidelines, a minimum of 5 hours of daylight in the public realm. Minimum of 5 hours of daylight. It's already there in the guidelines, and I'll show you why it's a minimum, because it just barely gets you enough sunlight. I'm going to talk a little bit about this. 10, number 10. R10, net effective building R value. I'm not sure how far you are in your technical studies. You'll probably know what that means. It means taking into account all the thermal ridging. But if you do that, then it'll be possible for you to make a net 0 building if you have a R10 net effective building area. 30% minimum open space at grade. This is a pretty soft one, but that's because in most of the hyperdensity projects, there's very little. It never gets to 30% in the hyperdense projects. What about setting a third of the site away for open space at grade? A third of the site. 45. If you've read the avenues and mid-rise guidelines, that is a number which seems like it's just something off your set square, an arbitrary number, nothing that's really important, 45 degrees. But really, it's not an arbitrary geometric number, which I'll explain shortly. It's not an abstraction, but it's actually a latitude-specific sun angle that defines the relationship that your building will have to the public realm, to the street, and to your neighbors. It's not just a number. And then 74. 74 is the energy use intensity of the building that I just did, which is a net 0 building. And I don't know if anyone speak energy use intensity? Anyone bilingual? Nobody. Okay. Well, we'll get into that in a little bit. Energy use intensity. That's the energy consumption of a building. What it means is that it's a very efficient building. And lastly, but not least importantly, of course, is that when you know how to achieve this city livability that we were talking about earlier, and you add these criteria, they're not going to replace all the things that were so eloquently discussed this morning, but you add these criteria as self-evident underpinnings of your work, then you'll have informed creativity, and you will use your own sense of urbanism and the urbanism that you're learning as you make your way through cities here and around the world, and your design mastery, and you'll make your buildings better. Let's talk about zero for a second. What is that? What is a net zero energy, or a zero net energy building? It's a building where you've made the building so efficient that it consumes so little energy that you can, at a certain point, afford to buy enough PV to balance that energy. So you've got very little consumption, you create energy, and you put the two together, the building is a net zero building. There's another way of looking at it. Energy use intensity. Energy use intensity is the energy use of your building in kilowatt hours per square meter per year. You've probably learned about that. And getting it low is going to be all of our targets, because we all need to be net zero by the year 2030, given provincial and federal aspirations, soon to be guidelines. Let's go about 5. The Mid-Rise and Avenues guidelines suggests a minimum of 5 hours of sunlight in the public realm per day between the equinoxes. And if you do that, if you get 7 hours, then you can have a typical lawn and a wonderful park. If you get between 4 and 7, you start having to deal with shade-tolerant plants. And under 4 hours, the plants won't survive, or they'll need a lot of help. Very limited planting. So that's just one aspect of why it's nice to have, what's important to have, that 5 hours of daylight. I'm sure you've seen, and there are, I think, plugins for SketchUp now, and maybe probably for Revit as well, this transition from shadow mapping to daylight mapping. And what an interesting change to think about, not the shadows, not the negative, but the positive. That the sunlight is the important thing. And this is, and it's such a significant issue that there it is in the Mid-Rise and Avenues guidelines, at least 5 hours of sunlight from the spring through the fall. But also you probably are aware that TO Core Building for Livability study, done by Perkins and Will, goes through a lot of things about livability, a lot of issues of livability, key challenges in the hyper-growth city, with small sites and view corridors and areas of transition. Other challenges being wind and microclimate. These are all things that you're going to be, you've talked about, and we've heard, in the discussions today. Podiumization and all sorts of different trends in infiltrating the high-rise buildings. Recognizing that Toronto is a very livable place, but it doesn't score top in any category. It only scores top in the aggregate of all the categories, which led the city to say, well, we've got to get ahead of this, because if we don't get ahead of it, as the city gains the 100,000 or 200,000 more people, these categories are going to become under stress. So they're suggesting that in the next 25 years, 225,000 more people, and they've been positing some performance criteria, some evaluation criteria for livability for these buildings. And you can get a hold of this document, it's online, it's in process. But not the least of which is that in this work plan that they've got, they're also talking about access to sunlight. And you can obviously tell where the blue areas are, that's where the high rise is, and where the yellow areas and green areas, that's where you're getting more sunlight. So I'm going to pause there and say it could be easy for any of us to look at it and say, well, I mean, there's nothing I can do. It's just a fact of the intensifying city. I think if you look around the world, you'll see that architects are actually believing that they can take these livability criteria into account and actually use them to shape their buildings, to provide access to places through building shape that you might not otherwise, access to daylight through building shape that you might not otherwise be able to do. So when I put forth these criteria, these possible design criteria, I guess what I'm saying is it's possible to actually try and use them to shape your building, to shape your space, to orient your courtyards, to orient your buildings by understanding how these phenomena are actually acting on your site. I work a lot with, I've actually lectured a lot with Steve Kemp, a very interesting guy, a scientist, an energy model reviewer, and I think he's been reviewing energy models for LEED for about 10 years now, a long time. And it's his opinion that, having seen all these energy models, that you cannot achieve a net zero building unless you're using a low temperature energy system. So chilled beams or radiant floors. Can't get there. So he said, well, if those are the only kinds of buildings that will achieve net zero, what do the architects need to do to make sure that that's possible? And from the cooling point of view, that's the sun access point of view, he said, well, we need a maximum of 35% window to wall ratio, maximum. And he's also positing, either with solar shades or with the glass quality, 0.27 solar heat gain coefficient. I don't know if you've gotten into that. I can assure you that in your very first project, outside of school and in the office, you'll see all these numbers come at you. So he says, well, that's that criteria. But at least as importantly is the R value of the building. And same thing, the limit of radiant flooring, or the limit of, in this case, VRF pumps. He's saying the building has to be an overall building R value of R10. Now you could think, well, the code says, R 20 walls and R 30 roof and R 4 glass. Well, those are the nominal R values. The effective R value is when you degrade all those by the thermal bridging, and that usually is by half or maybe even a third. So what does it really mean? It means lots of insulation and really good glass, like R8 glass. So think about that. We're only 13 years away from a net zero architecture world, and these things are not being discussed very much by anyone. And as I think I showed you in those first 4 projects, they don't limit design. They're just not talked about. Let's talk about 30. This is a weak one. And public work. Are they here? Did a beautiful job on Winford Green with this extraordinary mapping of a site near Don Mills and Eglinton Avenue, where they made a public space network, which blurred the boundaries between their site and the Don Valley, between their site and adjacent greenways, and it really put that in the foreground. First, we're making a public space network, and then we're developing the planning in between. And I thought that was a beautiful and very strong thing to do, especially when you're developing such an enormous site as this one is, as I said, at the corner of Eglinton and Don Mills. There's the actual plan of the site, and density in this site. So you can see there's CN rail track. Is this working? It is. Yeah, CN rail track up there. This wonderful green against the CN rail track, and the way in which public space is oriented and green space is organized around it. But the interesting thing for me was that they too, even in this house type, were under a lot of pressure. And there were, I think I identified 6 areas where sites that are being corrected by LGA and in Regent Park, where the housing is in an interior block with no access to the street, has become part of the project and has to be considered in order to reach their densities. And that made me wonder. I mean, we commented about it and when we reviewed it at Design Review, but it reminded me, of course, of Regent Park. And Regent Park, much like Alexandra Park, was one where innovative ideas about continuous green spaces were introduced, in this case in 1952, and it took almost 60 years to find a plan to get all those buildings to be back on streets again. There were things that made a lot of sense to architects designing in 1952, part of CM and part of the modern movement, which might have been truer in other parts of the world, but they weren't as true here in Toronto. And we're discovering that the street is the common planning element that we need to support as part of our public realm. I don't think I ever see more groaning about a requirement in the mid-rise and avenues guidelines than the number 45 and the 45-degree angular planes. And I can't tell you how many projects that I've seen, remember I've seen about 400, where someone says, well, you know, yeah, this is the angular plane, and I just popped through it just a little bit. It's like, what's the big deal? It's just a little bit. And you could say, well, if it's just a number and it's just 45, yeah, but as I mentioned at the outset, 45 is not just an arbitrary number. It's meant to help, it's meant actually to describe the relationship you have to the sunlight access in the public realm, sunlight access to the vegetable gardens of your neighbors behind you, sunlight access into the laneways, and it's been, I guess it's been trampled by so many projects that it doesn't seem to have relevance, but it'll have a lot of relevance on your site because you're at a mid-rise level and you can actually map these things out. You can see how light will play and will influence the use of outdoor space and the use of the public realm. This is view from my apartment, and that's King Street West. This is before a 21-story building was built on this side of the street. And I think it was just before the equinox. I think it's early in the morning. But the couple of points about this was that the issue of daylight access to the public realm, while discussed, wasn't as important as the precedent of another building down the street, which was of similar height, and so there should have been access to that same height by this developer. It's funny that the issue of this, our realm, not the realm of development, but the public realm, didn't really have any currency in that argument. So I ask you, as you make your way through your careers, as you are in your first or second or third work terms, as you go out, just think about the actual values underlying these abstract numbers. They mean something about making livability. And we talked earlier that that's what distinguishes Toronto, is livability. Again, a diagram which is much maligned, right? Oh, you know, look at the architecture that comes from this diagram. Oh, well, that's not the diagram's problem, right? That's us. We're architects. Just, you can make something beautiful with insulated metal panels. You can make something beautiful with anything. So just let's understand what these relationships are about, and let's go. Let's have some fun. And further to that, you may have some situations where you're dealing with existing buildings, you're dealing with high-rise existing buildings, you're dealing with laneways, and all those mid-rise and avenues guidelines, which when you look at them, they're a bit tiring in that manual. Understand them as the way that livability is made in Toronto. 74. I've never done a building with as little energy consumption as this one. And it is, and for residential buildings, it might be much lower. I think you can't get zero. You can get net zero, but you can't get zero. The building cannot exist without consuming some energy in 2017. So I think it's about getting to about 80% of the building code compliant building is where you'll get, and in a residential building be about 35. So here's a little primer on EUI. This is the amount of energy the building uses in a code conforming building. That's the size of the building, and that's its number. You just divide that by that. In the building that we're going to see in just a minute, it consumed that much. That was the area. So its energy use per square meter per year was 74. You're going to see that number in Toronto Green Standard version 3 a lot, because that's going to be a criteria for your building performance. It's not going to be LEED, and it's not going to be, there's going to be a building envelope criteria, but there's also going to be an energy criteria. And it's because it's easy to apply and see how it, well, it's not easy to get to, but it's easier than other metrics to understand how the building is performing. And this is that building. So it's filled with light. There are lights on, but it's filled with light. It's a great student space. It is, and as I said, it's also made of timber. We, as an office, Diamond Schmitt, we track all of our buildings through this tool that we have. We get the energy model data from the energy modelers. We put it into this software. It takes a little bit of time, and out it comes. And each one of these buildings has many, many, many pages of data that we can extract from it, so we can see. And here we are. We've been doing it for about 12 years now, and there's no trend in this. When you look at our overall portfolio, there's no trend. So when we look at that, we get very nervous. That's bad. But if we look at owner-occupied buildings, like rental buildings are, if you look at owner-occupied buildings, there's definitely a trend. And you know, you could put that line through there. It's not a steep enough slope for the scientists in the room. It's not a steep enough slope, but this is that building that I'm telling you about, the Okanagan College building. It gets down to 74, and we make 74 kilowatt hours per year of energy, and it's called net zero. In other words, the owner at the end of the year has a zero energy bill, no energy bill. And there it is again. Each region, Ontario, Quebec, BC, Alberta, has a different energy climate, energy purchase climate, as well as climate. And so there's no simple formula. I mean, I tried to put it down as 16 commandments. There's inflation even on religion. And I could spend time on each point, but I can tell you that having been through the process now a couple of times, the orange lines are the key ones. You got to focus on it. And the bottom one is, the minute things start getting complicated, you're headed in the wrong direction. It's got to be really, really simple. The other orange lines here that are surprising is that once you get a really good envelope and really good glass, we had a situation, we discovered that the this building in the winter was using more energy. Well, I'll pause on that one for a second. You need to provide 100% exterior sunshades during the summer, 100%. So that can either be through sunshades or through view dynamic glass or through dense glass, 100%. And why is that? Because if you've got this very simple mechanical system, if you get any direct rays of sun into your building, the mechanical system can't handle it, which makes balconies very good, by the way. Natural ventilation, good equipment. It's an iterative process. So we spent about a year going through model iterations before we could come up with those 16 commandments. And this is the code-conforming building. This is just the building using simple systems, good insulation, reasonable glass. And then we went back and forth testing miscellaneous equipment loads, optimized window areas. Optimized means much less glass, and making sure that it was in the right areas. Looking at mechanical equipment and seeing if we could use fewer fans. Then we went out for tender and we were still not right. And then we learned that we could schedule some of the equipment because it's not a factory, it was a school, and we went through all that detail, and the next thing you know, there we were, bingo, 74. And that's that building. So I would say these things here when anyone ever asks me, how do I get to net zero? What do I need to do as a starting point? Less glass than wall. Really, really good shading. An excellent overall building R value. And essential that you use a low temperature heat source. So extremely low energy consumption doesn't mean you can't have fun if you know what you're doing. So this is a project on McCall Street, just down the street from LGA. No, sorry, Bartolotto Architects, right. I'm sorry, pardon me. A little further down the street. Every other part of this addition, which was about 16 drawing studios and painting studios, was heavily insulated, except for this piece. And this piece, which is built in a little sliver of land 6 meters wide and about 70 meters long, was meant to be the student study areas facing McCall Street. But it's all glass. What's he talking about? Is he really going to stand behind his ideas? And so what we did was we designed the glass to be R8 and for it to be vision glass, so that for about 4 hours a day when the sun is on the east side, that it goes completely dark. And then when the sun comes around, it's only on the faces that are facing the sun, not the faces that are away from the sun. So you're looking south now, so the north faces of every one of those crystals doesn't have to go dark if it's not in sunlight. So there you go, I'll just show it a little bit faster. So all to say that we talked to the mechanical engineer and he said, if you've got the good glass and you've got the good solar shading, yes, you can do this. So the target was net zero for this project. Inevitably, when you're working on a project, you want to make sure that there's some dramatic moment in the project. And sometimes it's coming from you, sometimes it's coming from the needs of the project. And this is the project we're going to talk a little bit about, where we had to find a construction technique to be able to build a law school, so about 40,000 square feet of enclosure in 4 months, because that's the only period of time that the school was closed down. It was May until September. This is what their current building looked like. And we had to put an addition on the roof. It was a competition with 2 other Toronto firms. And it was beautiful, but we thought we might change it, this existing building. It's 400 feet long, and that's a 3-foot high window where the top of the window is about chin level. So we thought, we hoped that we could actually remove and make the window bigger. As it turned out, the architect had this be a continuous concrete beam, 400 feet long. And so we couldn't actually change the window, but we did do something else. So we was working with a team, Matthew Choi, Bolton Chan, Don Schmitt. We were sketching, and we thought, well, maybe we can find a way to get a lobby, a form that goes over this giant mechanical room, and a moot court underneath this big roof. And that sketch literally turned into that. All right, so that's the lobby, that's the mechanical room, and then just off to the right is the moot court. In order to get it to work and for us to understand what the design possibilities were, Matthew, one of the team members, built every single piece of the skin many times in order to understand how the pieces were going to come together, how it was going to be dropped in place. And this is what we got. And actually, this was the most dramatic moment before all the partitions came in, was this fantastic shell on the inside. And that's all 12 foot wide, or 3.6 meters by 12 meter long panels, fabricated in Delta, BC, put on a truck, sent here. And so that's their fabrication. All the individual pieces, that's still in their factory. That's them arriving on site. Looks like a skateboard park. There they are on the parking lot, being lifted into place. This key detail. First of all, these are 6 meter high, 125 millimeter diameter columns. Think about that for a second. So popsicles, no, straws in your physical model. And that saddle connection on one side is one prefabricated piece, and on the other side is the other prefabricated piece. So you can say, well, why is he showing me this level of detail? And I'm showing it to you because if there's a moment in your building that you really love, that is a gesture, that requires you to understand craft and the way, the sequence of construction, it's an opportunity for you to really get into it, to really dig in and understand it. Get into it empathetically. Think about how it can be built. Could you build it? And how would that happen? And so those are those straws. Right? Look at that. And I remember asking, well, actually my favorite story is that when these were being drawn by one of the architects on the team, he was drawing 125 millimeter columns, and the earlier version of these, which are timber now, were actually 250 millimeter deep steel beams. And I said, Matthew, come on, 250 millimeter steel beams for 12 meter span? And 125 millimeter columns, really? He said, you better talk to the engineer. That's what he told me to draw. And sure enough, not only was he right, but that's how it was built. And that's the space. We just reclad the bottom part and emphasized entrance. We weren't able to change the windows. The last thing I want to talk about is thinking big. And to I'm trying to remember her name, the bicycle factory this morning, Sonia? There you are. Great that you were thinking big. Don't be worried about thinking big, because about 10 years ago, if someone had said, you know, maybe Toronto could put a park over the railway lands, someone would have thought they were crazy. And density, growth, and public life, and popular opinion, and the fact that people are living downtown now. You all saw it in the newspaper. It's got a long way to go, but there are a lot of people who really want this to happen, and some pieces of it are actually already being considered in the eastern part of the railway. So something that would have been, if had it been in your thesis, everyone would have smiled politely and said, yes, that's really nice. Nice to dream big. And yet here it is as part of a potential future of our own city of Toronto. And then similarly, another great project by Public Work, the Under Gardiner project. Again, 20 years ago, talking about the Gardiner was like talking about a sewer, about an industrial backwater, about something that could never, ever be properly appreciated or occupied. And now there's great public enthusiasm and a private donor for a massive park. So thinking big is a good idea. So 0, 5, 10, 30, 45, 74. Do you believe?